Hello everyone, this is Shailesh Damle from Shimadzu Middle East and Africa, Dubai office. I welcome you all to Shimadzu's webinar on fast and reliable solution for pesticide analysis. The ever-increasing population require food in large quantities. To cater this need, many countries are in race to produce food in large quantities. But in this race, they may not follow good agricultural practices, leading to possibilities of adulteration as well as contamination. In today's webinar, we'll discuss how Shimadzu's UFMS technology evolved over past decade. Before we go and discuss about pesticide analysis, we'll discuss about what is pest and what is pesticide. Then we'll discuss about general workflow for multi-residue analysis. Then we'll also discuss about what are the common challenges faced by testing laboratories, followed by Shimadzu's UFMS solution to overcome those analytical challenges. This is the chronology of our triple quadruple mass spectrometer development. Our first triple quadruple mass was launched in August 2010. It was the first triple quadruple mass with achieving world's fastest scanning speed of 15,000 masses per second and 15 millisecond polarity switching time. In following years, Shimadzu launched GCMS, LCMS, ICP-MS series instruments almost every year with UFMS cutting edge technology and with improved specifications. The UFMS technology is based on ultra-fast scanning, ultra-fast MRM and ultra-fast switching. Combining all these, it gives high speed of analysis as well as sensitivity. Before we go in details of pesticide analysis, it is important to know what is pest and what pesticide is. So pest can be defined as any animal, plant, microorganism that causes trouble, injuries, we can say as economic damage or destruction to plant or crop. The common pests include as insecticide, bacteria, fungi, rats, we can call it as rodents or even weeds to that matter. So based on that, pesticide can be defined as any substance or mixture of substances intended for preventing, destroying, repelling or mitigating any kind of pest. So pesticide can target either insect, so we can call it as an insecticide, rat or mice, so that category can be called as a rodenticide, weeds, so we can call it as a herbicide, and fungi, we can call it as a fungicide. These are some of major regulatory bodies working globally to make our food safer for consumption. To name few, Japan's positive list, India's FSSAI, Singapore's AVA, etc. Among these, Europe's EU holds a special place as it sets and follows most stringent regulations for food safety. This is typical pesticide residue analysis workflow. There are different steps in sample analysis. Some are called as a pre-analytical, some are called as a post-analytical. Every step is critical and pose different challenges to testing lab. Mostly sample comes in a different form. So we need to use different tools and technique for sample extraction as well as sample cleanup. Sample cleanup is essential that reduces interferences which are coming from sample matrix. Once sample cleanup is done, we need to study recovery as well as precision. This study is mostly carried out at the time of method development and method validation. For routine analysis, we can directly prepare a calibration solution which is from low concentration to high concentration. This calibration solution is essential for doing accurate quantitation. Once your calibration solutions are ready, your sample is ready, you can take that sample to analysis on either GCMS or LCMS or sometimes both. The choice of GCMS or LCMS depends on what kind of pesticide you are targeting. Once your analysis is finished, it is equally important to make a conclusive report of the analysis. There are many challenges faced by testing lab in sample analysis, starting from sample preparation to data review, data processing and reporting. In terms of sample preparation, you know that food matrix is always complex. So user need to have easy sample preparation rugged and robust instrument for analysis. Once sample is prepared, it is equally important to make instrument method. The method is always for multi-residue as well as multi-class. So user need to purchase multiple standards. The requirement is there should be easy way of method creation, multiple MRM for each compound to provide more selectivity. In terms of sample analysis, to improve the throughput, always there is a requirement for large number of sample analysis. At the same time, there should be maximum pesticides in a single run. After analysis is finished, it is always challenging to review the big data which is acquired, as well as to process data and to make a meaningful report. So the biggest challenge is to create and handle the big data which is acquired. So we need to have a quick, accurate data review as well as easy report function. Moving to specific sample preparation challenge, matrix is always complex and diverse, and the residues which are present are usually present at very low concentration level. So we need to have sample preparation. We need to extract sample to have a better sensitivity. Even if you consider simple water, we need to have some at least liquid-liquid extraction step to make residue free-form matrix. Now, co-extraction is always a challenge. Whenever you extract sample, there is a matrix component is also extracted. That gives very high matrix effect. After you prepare a sample, we need to have effective cleanup also in order to remove background interferences. All these extraction steps sometimes very tedious. That is the reason why the recoveries are always low. In order to have a better selectivity and sensitivity, mass analysis is always essential. The most popular and convenient tool for sample preparation is Quecher. Quecher stands for quick, easy, cheap, effective, rugged, and safe. Shimadzu can offer Quecher kit for improving your sample preparation with ready-to-use extraction salts and pre-wet DSP tubes. The main benefit of Quecher involves in significant reduction in extraction time, solvent as well as glacier uses, giving overall economical and eco-friendly solution for all older methods. Shimadzu offers sample preparation handbook for multi-residue pesticides. These guides to select proper Quecher kit for different types of food matrix. Quecher sample preparation steps are very easy and simple. It also saves a lot of time. It gives cleaner sample for analysis by LCMS as well as by GCMS. First, sample need to be homogenized by blending it, followed by a step of extraction. So extraction can be done by adding isonitrile along with internal standard, then by shaking vigorously for 1 minute. After that, the buffer salt can be added. We can mix it and centrifuge for 5 minutes to separate the phases. Then finally, separated phases can be transferred to a tube containing a suitable adsorbent. After that, mix it by shaking, separation by centrifugation, and transfer the clear solution to autosampler vial. The better sample preparation not only improves the quality of analysis but also reduces contamination in MS system. That also reduces the frequent breakdown of the system. The effectivity of Quecher cleanup can be seen by comparing all these chromatograms. We can see the endosulfan peak is completely masked by matrix interferences. After cleanup, we can see there is a drastic reduction in matrix interferences, as well as there is a good improvement in peak shape as well. These are different combinations of extraction salts and cleanup kits available. Based on the commodity as well as matrix to be extracted, we can select a proper salt for extraction as well as a proper cleanup solution. There might be many trials and errors involved in optimizing sample preparation. In that scenario, simultaneous analysis in scan and MRM mode available with Shimadzu can provide very useful information. Scan data helps in understanding the effectivity of sample cleanup, that is qualitatively, and MRM mode helps in understanding the recovery via quantification. Also, based on compound, if it is identified what is interfering, the sample cleanup procedure can be modified. After sample preparation, next part of the workflow is creation of method for quantitative analysis. For quantitative measurement in GCMSMS, one required to optimize MRM transition and collision energies for each pesticide to be analyzed, which is extremely labor intensive. For ease of method creation, Shimadzu provides smart databases for various applications like environmental, metabolites, forensic. But in today's discussion, we'll discuss about smart pesticide database. As you can see, using smart database, MRM method creation can be done within very few clicks. The method has been more than 500 pesticides registered with their CAS numbers, MRM transition, and optimum C values. For method creation, simply user has to obtain retention times, and with few clicks he will get MRM method with optimum time segment, provides best efficiency and selectivity. RTs can either be obtained by analyzing individual pesticide standard, again which is going to be very costly affair. Alternatively, since this database contains retention indices, retention times can be predicted with a single N-alkane analysis via ART function. Using the predicted retention times, user can create MRM methods without purchasing or analyzing any analytical standard. Both these features, that is use of retention indices in database and ART function in a software, are unique for Shimadzu. This ART function not only helps in creating method but also helps you whenever you modify method parameters for optimization or you perform column maintenance like column cutting. As you can see from this graphic, with the help of NLK standard, it automatically adjusts identification window, that is data processing parameters. This ensures you don't lose any peak. This helps you especially when multi-residue analysis where large number of peak elude at very close to each other. Well, so far we have discussed about the pesticide present in the database, but now we'll see what if the analyte is not there in database. In that case, smart optimization tool will help to optimize MRM transitions automatically and store in the smart database for MRM method creation. Now, you can register up to 10 MRM transitions in the database. For most of the cases, definitely you don't need that many. But for complex matrices like spices, additional MRM can provide option in terms of selectivity. After sample preparation and method creation, next step is a data acquisition. In this, the real challenge is the analysis of large number of sample. Each sample contains more number of analytes and that to be analyzed in shortest possible time. This can be done with UFMS technology, which lies at the core of Shimadzu GCMSMS as well as LCMSMS. As you can see in this chromatogram, the simultaneous analysis of more than 400 pesticides and approximately 1200 MRM transitions in a single run. That too, a very low concentration of 5 ppb in a complex matrix like spinach. Data acquired shows very good reproducibility. Most of the analytes show RSD less than 10%. On one side, you can see conventional method workflow, where you extract test sample and prepare standard solution. Then you prepare a matrix match linearity. The batch is acquired including linearity as well as test sample, followed by data acquisition and reporting, which would take at least 2 to 3 days to complete whole process. On other side, you can have a quick DB workflow, where you can simply extract test sample, spike it with quick DB surrogate, and analyze to obtain semi-quantitative results. Sometimes the semi-quantitative results are enough to release sample. The good thing about that is this does not require authentic standards. Let us see how QuickDB improves the accuracy over other conventional internal standard methods. As you can see in the first case, that is conventional internal standard method, the difference between the analyte and the internal standard intensity in the database is not consistent with the actual test sample analyzed in lab. This is basically due to the matrix effect. As selection of internal standard is not proper, the matrix affects analyte and internal standard differently. Whereas in case of QuickDB, there is a minimum deviation which results in better accuracies. This is because the QuickDB The isotypically labeled internal standards are selected and grouped after carefully studying the many properties like polarity, solubility, boiling points, etc. They cover more than 450 pesticides present in the QuickDB database. Apart from this, it can help in reducing the cost and also handling of harmful chemicals. Also, in addition, there is an inbuilt system status check protocol to ensure the reliability of the data you acquired. It uses instrument check solution, which is included in QuickDB kit. It indicates the condition of the system throughout the QA/QC check function, based on which you can pinpoint the specific hardware component responsible for contamination. User can also check the contamination level and pick shape as well. At the end, user can get complete evaluation report of QA/QC check. Shimadzu has recently launched the latest version of LCMS pesticide method package version 3. It has more number of pesticide details and covers most of the global regulations. It has 836 pesticides with more than 6,500 MRM transition. It also gives auto-sampler pre-treatment program to improve peak shape of the polar pesticides. The three method files are provided with two different columns detail. LabSolutions Insights, which comes along with the LabSolution, helps to process large data effectively. User can find all method details in the method package and the instruction to select the required components for the method package. We can see there are a lot of co-eluting peak which are easily be handled by Shimadzu's UFMS technology. The important feature of the new method package is that it is compatible with LabSolutions MRM Connect software. In 3 simple steps, user can create acquisition method. User can load entire 836 compound using LabSolutions Connect. In the second step, user can specify target compound and the number of reference ions. Method can be created based on this input, which will be ready for further use. This is really very good example for food safety sector. In pesticide analysis, samples are typically extracted by quencher technique, where samples are diluted in 100% of acetonitrile in last stage. When we inject such sample, the early eluting peak show fronting. This is mainly because of the polarity difference between mobile phase and sample diluent. To avoid that, some laboratories evaporate acetonitrile and reconstitute the sample with a mobile phase composition. But Shimadzu has a unique solution for that. We call it as an auto-sampler pre-treatment program. Here, with the regular sample injection, we introduce a little amount of water, which alters the diluent composition, which helps to improve peak shape. As you can see, there are 12 pesticides are eluting in the window of 9 seconds. The system shows robust detection with very low RSD for 6 consecutive injections, even if all the peaks are almost co-eluting. This proves the capability of UFMS technology. Multiple reaction monitoring based LCMSMS technique are widely used on triple quadrupole platform for targeted quantitation as a result of high selectivity, sensitivity, and robustness. For pesticide analysis in EU, identification criteria in SANTE guidelines requires retention time and ion ratio from at least 2 MRM transition to be within acceptable tolerance limit of retention time is within window of plus minus 0.1 minute and ion ratio for at least 2 products should be plus minus 30%. However, even applying this criteria, it is well reported that false positives can occur in a certain pesticide analysis. To reduce false negative and false positive reporting, a higher number of MRM transitions were used for each targeted pesticide to increase the level of confidence. The number of fragment ion transitions monitored for each targeted pesticide was actually dependent upon the chemical structure of pesticide. However, typically between 6 to 10 fragment ions for each compounds can be monitored in MRM spectrum mode. MRM spectrum mode combines conventional MRM quantitation with the generation of high quality MRM product ion spectrum which can be used for routine library searching and compound verification and identification. In this example, intensity axis is same for both conventional as well as MRM spectrum mode. It shows that response is not changed with MRM spectrum mode. MRM spectrum mode help to reduce false positive or false negative reporting by comparing multiple fragment masses. In this example, except few, desmediform and phenmediform have similar mass fragmentation. If data was acquired for only two transitions, then there was a high chance of false reporting. With the help of MRM spectrum mode, such false reporting can be avoided. Also, if required, MRM transitions can be swapped between qualifier and quantifier to get better result. Not only that, other peak shape of other transitions can also be checked. This is the overview of LabSolutions Insight software window. All the samples in the batch, compound list, quantitation graph and calibration plot can be seen at a glance. View can be changed to sample view, compound view or summary view. The quantitation graph displays the target ion as well as reference ion. The view can be changed as per the requirement. One can easily change the target ion and observe the impact on overall results as well as on calibration curve. The calibration plot, there is a facility to modify the parameters like weighing method or fit type, and the impact can be seen in the same window. This is the compound view. Based on the requirement, user can select this. It shows result of single compound for all the samples in your batch. This is sample view, where results for all compounds for single samples can be seen. This is the sample survey mode. The sample survey mode can give a glance at all the chromatograms. It is easy to understand. We can check the peak shape, we can check the integration parameters, we can see the integration, and also it will help to improving processing parameters. Also, data processing and data review becomes easier with additional options like flagging, filtering, and sorting, which look similar to Excel but much more refined. For example, one of the filters displayed here is for concentration limit, review, or outlier. Similarly, flag criteria can be applied to many validation parameters like accuracy, RSD, ion ratios, etc. It effectively handles huge amount of data with multiple analytes. The reporting becomes easy and also minimizes error. The data can be filtered or sorted by different flagging criteria. One can easily see the failing sample by colored. So, Insight becomes a tool for multi-residue analysis. Some of the labs who are serving various customers need to submit their reports differently. Depending on the scope needed by the customer, they can customize the template and store. So, it will automatically only publish those compounds in the final report. As per the customer requirement, selectively reports can be generated for their scope. Just like the flexibility provided throughout the data processing and data review, the software also has flexibility in reporting. There are templates like compound-wise, summary reports, or individual test sample reports can be generated, which will include necessary validation parameters like RSD, recovery, ion ratios, etc. So, as we come to the conclusion part, this is how Shimadzu UFMS provide total solution to various challenges faced by testing laboratories along their entire workflow. Feature-based sample preparation, effective accessories, hardware features like auto-sampler pre-treatment prove to be helpful in handling complex matrices. Smart database with pre-register optimized MRMs for more than 500 pesticides for GCMS and more than 800 pesticides for LCMS, covering various classes and ready-to-use method packages. It helps significantly in creating multi-residue method without any error. UFMS technology enabling acquisition of multi-residual methods in a single run, accompanied with plug-and-play solutions like QuickDB, and LCMS residual pesticide version 3 will enhance the throughput and the productivity of laboratory. And on the top of it all, much needed user requirement of ease data processing and reporting is well addressed by LabSolutions Insight software. This concludes the topic. Thank you all for attending. Experience the Shimadzu's UFMS technology in your lab.
Excellence in science. Shimadzu.